Hello everyone, welcome to my channel. In this session we are going to solve a big M method, okay, for a given LPP problem, right? There are certain LPP problem where the slack variable cannot provide solutions to you, okay. Usually in the last video you can see that all the problems whatever I solved was the less than or equal to, right? The inequalities constraints, what you can see there was all less than or equal to. So now in this problem what you can see here is we have one equal to symbol and one is greater than or equal to, another one is less than or equal to. Okay, there are certain limitations for the ordinary simplex method wherein the greater than or equal to symbol cannot be solved using the normal method. So we have to go further using the big M or penalty cost method. Okay, so this is the way or the problem or the approach what you can consider to solve such kind of problems. Okay, so now what we need to do is we will take up the problem in the same way as I explained in my earlier lecture. Okay, but instead of considering only the slack variables, two other new variables are going to get introduced in this problem. Those are surplus variables and artificial variables. Okay, so you can see the first constraint that I written 3x1 plus x2 equal to 3. So in such case, whenever there is an equality conditions, there is an introduction of the artificial variable. So there won't be any kind of slack variable and surplus variable, there will be only artificial variable. But in case of the second constraint, we have 4x1 plus 3x2 greater than or equal to 6. So in that constraint there is a introduction of surplus and artificial variable. So it will be rewritten as 4x1 plus 3x2 minus s1 plus a2 equal to 6. Okay, so surplus variable, whenever you introduce you have to subtract it. So the symbol will be in the negation, okay, minus, right? And the third variable, you all know, there will be introduction of only the slack variables. Okay, and then we will try to derive the initial basic feasible solution for the given problem, and then using the same tabular column, no, we will solve the problem. Okay, so here M represents the penalty, right? So let us see how we can solve this problem. So first of all, as I told you that we have to convert this all inequalities into the equality conditions, right? Okay, in the first constraint we have it in equality, rest all we do not have. We have it either in greater than or equal to or less than or equal to. So now we have to convert everything into the standard form. So how do we do that? So what we do is, first I will write max z. Okay, so I will write max z equals 2x1 plus x2, 2x1 plus x2. So I need to write further. So as of now I'll not write, later I will write once I write on the constraint. So first I will focus on the constraints. So the first constraint will be written as 3x1 plus x2. Since we have equal to 3, so there is an introduction of only artificial variable, so that is a1 equal to 3. Okay, the second constraint will be written as 4x1 plus 3x2. Okay, and now since it is greater than or equal to, I will have one surplus variable, that I will write it as minus s1, and one artificial variable, that is plus a2 equal to 6. Okay, and the last constraint is only less than or equal to, so I'll rewrite it as x1 plus 2x2 plus s3. Okay, sorry, not s3, it is s2 equal to 3. Okay, s2 equal to 3. Then finally I write all the basic and non-basic variable to be greater than or equal to 0. So that is x1 comma x2 comma s1 comma s2 comma a1 comma a2, all are greater than or equal to 0, right? After I do that, I just need to find out the initial basic feasible solution. So how we will do that? So what I need to do is here, first I will write the side heading initial basic feasible solution. To derive the initial basic feasible solution, we have to check here wherever we have artificial variable. So you can see artificial variable appears in the first and the second constraint only. So whenever it appears here, So we have to check how many basic and non-basic variables we have. So we have two non-basic variable, that is x1 and x2, and also we have one basic variable, that is s1. So we have to make all these basic and non-basic variables to 0, that is x1, x2 and s1 we are going to make it as 0. This particular equation we are not considering because there is no artificial variable. So we are considering those constants where there is an artificial variable. So now what we write is we will write x1 equal to x2 equal to s1 equal to 0. If I initialize this 0, so now you can understand what is the value of a1. So you can determine the value of a1. a1 becomes what? 3. a2 becomes what? 6. And s2 will become 3. And you can also check for the z value, right? Max z will become what? Z will become what? Okay, so to do that we have to continue this further. See, as I told you already, 2x1 plus x2. So we have one slack variable, right? So I will rewrite this as 0 s1. Okay, right? And we have one surplus variable also. Okay, slack variable, surplus variable. s1 is a surplus and slack variable s2. So I write 0 s2. Okay, and then I have two artificial variable a1 and a2. Since the problem is of maximization type, I will write it as minus m. Okay, minus m into a1, and second artificial variable minus m into a2. So make a note of this. Okay, first what I did is 2x1 plus x2, that is same as that is there in the question, and then you can see in the constants we have introduced two variables, that is slack and surplus, right? So that I'm going to make it as 0 s1 and 0 s2, and then we can see that we have the two artificial variables, that's a1 and a2, and since the problem is of maximization type, I need to write minus m. If it was minimization, I would have written as plus m. So please make note of this point. Okay, so I wrote it as minus m into a1 and minus m into a2. Now you can equate this x1, x2 and s1 to 0. So what is the value you get it for z? So if you do that, see, 2x1 is that's 0, x2 is 0, s1 is 0, s2 is also 0. So it is minus m into a1. What is the value of a1? We got 3. So it is minus 3m and minus 6m. So this will give you minus 9m. Okay, minus 9m. So this is the initial basic feasible solution what we got here, right? Now what we will do means we'll try to find the actual value of z value and also the value of x1 and x2. Okay, so let us try to solve this problem using tabular simplex method. Okay, using the penalty method or the bigger method. Okay, now I'm going to take up all the values here. So what I will do is first let me take the value of all the basic and non-basic variable, that's x1. Okay, I'll take it as x1, then it will be x2. After that I have s1, right? Then I have s2, then I have artificial variables a1, I have a2, right? And then I have RHS value, then finally I have the ratios. Okay, and above that, what are the CJ values? CJ values is these are the z values. Okay, so it is 2x1, right? 2x1 plus x2, so I will write it as 1 here, and then s value is 0, s2 value is 0, a1 and a2 value is minus m, right? Minus m, and here also minus m. I need to write like this. Okay guys, and here also so the first row you see, in the first constraint, you see, look at the first constraint. In the first constraint, do you have any artificial variable? Yes, if you have the artificial variable, okay, in the first constraint you have to write it as minus m into a1. See here minus m into a1. First constraint you had the artificial variable, that's why. Second constraint, do you have the artificial variable here? Yes, we do have, right? Then we will write the second constraint also as minus m a2. Yes or no? Minus m A2. And the third constant, you see, third constant, do we have any artificial variable? We do not have. In that case, what do we have? S2, right? So we'll write S2 as, how we will write S2 as 0 S2. Okay, so I will write it as 0 S2, 0 S2. Okay, now you can fill all the constant values in this column. Okay, so first I will write all the first constant, that is 3. Then you can see the question 3 1 0. This will also become 0. A1 was there 1, A2 was not there 0. RHS value was how much? 3, correct? Similarly you go for the next. Okay, so next value is 4. Then we have 3, then we have minus S1, right? So it is minus 1, so we do not have S2, so that's 0. Then we have A1 is not the 0, A1, A2 is there 1, and RHS value is 6. And for the 0 S2, so the last value is 1, 2, 0, and then we have 1, right? 1 2 0 1, yeah. Then A1 and A2 is not there, that's 0 0, and the last value is 3, correct? Okay, is 3. Now what we need to do, guys, is, I hope you understood till here. Okay, as per the question we have written the values here. Now what we need to do, we have to calculate the value of Zj and Cj minus Zj. Okay, now how to do that I'll tell you. So after that you put a line here. Okay, then we'll write Zj value. So Zj will be considered as this one, minus m into 3. Okay, you have to keep on adding. Okay, minus m into 3 plus minus m into 4 plus 0 into 1. What is the value that you have to write? Just to multiply the Cj with the all the values what you written inside the columns. Okay, one by one column we have to consider. So what is the value now? Minus m into 3, that is minus 3m minus 4m. So minus 3m minus 4m will become minus 7m plus 0 into 1 0. So what is the value of Zj now here? Minus 7m. Okay, similarly go for the second column, minus m into 1 plus minus m into 3 plus 0 into 2, minus m minus 3m, that's minus 4m. Okay, then we go for the third column, minus m into 0 0, minus m minus 1, so that's m, right? So this will become m. So together we have to add. Okay, that's the summation of all the multiplications there. So minus m into 0, minus m into 0, 0 into 1, so this becomes 0, and minus m into 1, so that's minus m. Here it is again minus m, and this becomes minus 9m. Yes or no? Right? Minus 9m we got. Now we'll go for Cj minus Zj. Cj values we are already written at the top. You can see that 2 1 0 0 minus m minus, that are all Cj value. Now we'll just subtract Cj with Zj, and let us see what is the new set of values we are going to get. So 2 minus of minus 7m will give you 2 plus 7m. 1 minus of minus 4m will give you 1 plus 4m. Okay, 0 minus m is minus m here, right? Minus m here. 0 minus 0 is 0, minus m minus of minus m, that's 0. Okay, and again minus m minus of minus m, that's 0. Okay, so that's all. Right, now what we need to do means, out of these values you can see that only we are considering the value of m. Okay, highest value for m will always be considered. We have now we should see that whether we have reached the optimal solution or not. We are not reached, because we have one negative value for them and rest two are positive. That means we have to proceed further for the first iteration. So out of these, which value we are going to select is the highest value for the m. So that is this one, so we are considering this, right? And when we are rounding off the values, we have to round off only for the constraints, not for Zj and Cj minus Zj. Okay, only for this 3 4 and 1. Okay, and now we will take the ratios. For the ratios, what we need to do, 3 by 3 is 1, you all know that. 6 by 4 it will give you around 1.5, and 3 by 1 is 3. So out of this, which is the least value, that's 1. So I will consider this as the leaving vector. Okay, and I'll round off the entire row. Okay, entire row. So here 3 has become the intersection. right? Now you all know what is the formula. That's so you have to make 3 as 1, 4 and 1 as 0. So what is the formula? You have it there. So what will be the formula? So how will you write the formula for R1? R1 will become R1 by 3, correct? Then only we can make it as 1. R2 will become R2 minus 4 into R1, right? Minus 4 into R1, and R3 becomes R3 only. Since we have 1, so we will write minus in 1 into R1. So now you have to substitute these values, okay, and you have to get the new improved solution. So what will be the solution here? So all of you can work out on your own and you can get the solution, okay? I am writing the direct values here, okay? Substitute all the formulas values here, okay? Whatever you got here. Now first you have to solve the first row, okay? And now there is one small change what you need to do. I'll tell you what to do here. See here. Now what was the value here? 3 was the intersection variable. Since 3 is an intersection variable, now this minus m into a1 will be replaced by the 2x1. Remember, which is the intersection here? 3 is the intersection, so minus m a1 will go out, okay? It is going to leave us, and this will be the leaving vector. In place of this, what will come and sit? 2 into x1. So what I will do here is I'll write 2x1 there, okay? 2x1 here, right? 2x1. And that's next I will apply the formula R3 by R1 by 3. So this will become 1 and this becomes 1 by 3. This is 0, 0, and since, see, have a look of this. So minus MA1 has already left us, so there is no point in calculating that. So I will not going to calculate it, so it is dash, and minus MA2 I will get it as 0, okay, and the RHS value will be 3 by 3, that's 1. Okay, similarly let us go for the second one. So R2 formula is R2 minus 4R1, right? So what is the formula? So here it will be same, okay, minus MA2 only, minus MA2. This will remain same because it has not left us yet, and the value will be 0, okay, 5 by 3, 5 by 3, and this becomes minus 1, 0, okay. This we are not going to calculate, and this 1, and next is 2. Similarly for R3 minus R1, so this becomes same, this will remain same, that's 0 is 2, and here it will be 0, this becomes 5 by 3, this is 0, 1, okay, we are not going to calculate that, and this becomes 0 and 2, okay, done. Now we have to calculate the new set of Zj and Cj minus Zj, right? Cj minus Zj. Okay, Cj will remain same, only Zj values are getting changed now. Cj is same, okay. Cj, when you see this 2 1 0 0 minus m, that is same. Now only Zj. So how will you compute? 2 into 1, 2. 2 plus minus m into 0, 0, 0. So what is the value of Zj now? It's 2, right? You add. Okay, 2 into 1 plus minus m into 0 plus 0 into 0. That's 2. And next 2 into 1 by 3, that's 2 by 3 minus 5m by 3, correct? No, minus 5m by 3. 0 into 5 by 3 is 0. So next is 0 minus m into minus m, minus 1, that's m. So this is m, 0, 0, 0. So this will become 0. This we are not going to calculate, and this will be 0 minus m, okay, minus m. This becomes 2 minus 2m, right? So that is the end of the Zj, and Cj minus Zj, 2 minus 2, that's 0, okay. Please consider this, the values, okay, the upper value 1, and that you have to subtract with this value, okay. So what is the 1 minus 2 by 3 minus 5m by 3? So that will give you the answer how much? 1 by 3 plus 5m by 3, okay. Next will be 0 minus m, that's minus m. This becomes 0, this we are not going to calculate, and this becomes 0, and this we are not going to calculate, okay. So that's the Cj minus Zj values. So you can verify the answers, okay, if you are solving along with me, right? Now still we can see that one m value is 5m by 3, it's positive, another m is still negative, right? So we cannot proceed, we cannot conclude this as an optimal solution. We have to proceed further for the second iteration, guys. So which will be the entering vector here? Out of 5m by 3 and minus m, 5m by 3 is having the highest value, so this will be the entering vector, and you have to consider this particular column as the entering vector. Okay, and now we are going to find the ratios here. So what will be the ratios? So we are considering the ratios, right? So 1 by 1 by 3, that becomes 3 here. Okay, ratio here it will become 1 by 1 by 3, 3, 2 by 5 by 3, okay, 6 by 5, that will give you around 1.2 somewhat. Okay, and 2 by 5 by 3, 6 by 5, that is again going to give you 1.2. okay, now as you can see there is a tie, right, between these two values, 1.2 and 1.2, and I already told you in my earlier lecture that whenever you get a tie, so what you need to do, you have to divide it with the slack variables. Okay, so what is the slack variable here? So one second. So what is the slack variable here? So the third column is a slack variable, right? So we have to consider only this one, right? Okay, so minus 1 by 5 by 3 you have to do. Minus 1 by 5 by 3 is always a negative number, so we are not going to consider this value. So what is left then is 0 by 5 by 3. So 0 by 5 by 3 is always 0. So now we are going to consider the third row as the leaving vector. Okay, so this will become the selected row. Okay, now this 5 by 3 has become the intersection variable, and now we have to make this 5 by 3 as 1, rest of the 5 by 3 and say this 5 by 3 we have to make it as 1, this 5 by 3 and 1 by 3 we have to make it as 0. So what will be the new formulas for R1, R2 and R3? So that we are going to write now. Okay, so write the formula for the R3 first. So R3 will be what? R3 will be 3R3 by 5, correct? No, 3 into R3 by 5, so that will make the value as 1. If I want to make R2, so what is R2? R2 is equal to R2 minus 5 by 3 into R3, correct? And R1 will be R1 minus 1 by 3 into R3. So this is the formula, right? This is the formula for the second first iteration. Now we have to use this formula and do for the second iterations. Okay, now we have to solve it. So apply this and write down the values. So what will be the answer? First you have to solve the third row. Okay, now as you all know that 5 by 3 intersection we got, right? That means 0 into S2 will leave us, right? So 0 into S2 will be rewritten as what? 0 into S2. Okay, the second column, let us see what is there in the second column. That is 1x2, guys, 1x2. So we have to replace this, right? 0 S2 will be replaced by 1x2, correct? No, because we have that intersection variable, so where it is intersecting, that the CGM the top column values has to be written in place of this row value. So 0 S2 will be rewritten as 1x2. Okay, so now I'll solve the problem using that after doing all these changes. So what I will do means first I'll extend this line. Okay, yeah, so I'll extend the line. So I wrote 2x1, okay, and then the values will be, what will be the values for the first row? R1 minus 1 by 3 into R1. Okay, so this will become 1. Okay, so before we'll do one thing, we'll first solve the last row, because we got that as we have to make that 5 by 3 as 1, no? So I'll write this one as minus ma2, that will remain same, this will remain same, and then we have to go for 0s2. 0s2, as I already told you, it will be replaced as 1x2. Okay, now I'll solve this third row first. So this will become 0, so the r3 is 3r3 by 5, and this becomes 1, next is 0. Okay, after that it is 3 by 5, next we are not going to compute this one, and then it is 0, and after that it is 6 by 5. Okay, similarly now we'll go for the first row, that's 2x1, that's become 1, and by applying the formula for r1, that's r1 minus 1 by 3 into r3, so that will give me 0 here, and this will also become 0, minus 1 by 5, and this we are not going to compute, and this becomes 0 and 3 by 5, and minus ma2, this becomes r2 minus 5 by 3 into r3, so the values will be 0, 0, minus 1, this becomes minus 1. Okay, and this we are not going to compute, this is 1, and this becomes 0. Okay, yeah, now we are going to compute the value of zj, right? Zj and cj minus zj, cj minus zj. So let us compute the values here. So zj is 2 into 1, 2 into 1 minus m into 0 plus 1 into 0, so that's the answer is what? 2, right? So we'll write 2 here, and here also 2 into 0 minus m into 0, 1 into 1, so it's the answer is 1. This becomes m, right, and this becomes minus 2 by 5 plus m plus 3 by 5, so it is 1 by 5 plus m. Okay, 1 by 5 plus m, and then this becomes minus m, and this becomes 12 by 5. Correct? Cj minus zj, cj values are same, that's 2, 1, 0, 0, minus m, right? So we'll just subtract 2 minus 2 is 0, 1 minus 1 is 0, 0 minus m is minus m, and then we have 0 minus 1 by 5 minus m, so it is minus 1 by 5 minus 1 by 5 minus m, this is done, and this becomes 0, this we are not going to calculate. Okay, that's the answer here, and we can clearly see that both the values of m is negative and rest all are 0. In this condition we'll stop doing further iterations. Okay, because if I multiply this with the minus 1, you'll get plus m with the 1 by 5 plus m. Okay, so either you have to get like a negative value and one positive, in that case we have to proceed further, but in this case all are 0, 0, 0, 0 here, only these two negative values are negative, so in such case we will not proceed further, we will wind up the solution here itself. Okay, and now we have to see what is the value of z max, right? So what is the value of z max here? So as I told you, zj is here, right? Now towards the RHS value. Okay, zj is here, what is the RHS value of that? That's 12 by 5, so I'll write it as z max or max z equals to 12 by 5. Okay, at what is the value of x1? X1 equal to how much? X1 is the first column, right? 1, so 1 is pointing to 3 by 5, so that is 3 by 5. Okay, so 1 I will write it as 3 by 5, and x2 will be what? 0, 0, 1, so you can see in the second column it's 0, 0, 1, so 1 is pointing to 6 by 5. Okay, x2 will be 6 by 5, done. Okay, so if you substitute this to the main problem, no, you will get your answer, right? So what was the question asked? What was the question here? So question was max z is equal to 2x1 plus x2, right? So what is the value of x1 you got? x1 is equal to 3 by 5. So it is 2 into 3 by 5, 6 by 5 plus 6 by 5. That's 12 by 5. So z also we got 12 by 5. So LHS equal to RHS. That means the final optimal solution for the maximization z is 12 by 5 at x1 equal to 3 by 5 and x2 equal to 6 by 5. Okay. So if you have any queries regarding to this problem, okay, please do let me know by dropping your comment in the comment section below. Thank you so much for watching.